our solar system is no longer the sole record holder for most known planets circling a star. An artificial intelligence algorithm sifted through data from the planet-hunting Kepler Space Telescope and discovered a previously overlooked planet orbiting Kepler-90, making it the first star besides the Sun known to host 8 planets. This finding, announced in a NASA teleconference December 14, shows that the kinds of clever computer codes used to translate text and recognize voices can also help discover strange new worlds. The discovery, also reported in a paper accepted to the Astronomical Journal, can also help astronomers better understand the planetary population of our Finding systems like this that have lots of planets is a really neat way to test theories of planet formation and evolution, says Jeff Coughlin, an astronomer at the SETI Institute in Mountain View, California, and NASA's Ames Research Center in Moffett Field, Calif. Kepler-90 is a Sun-like star about 2,500 light-years from Earth in the constellation Draco. The latest addition to Kepler-90's planetary family is a rocky planet about 30% larger than Earth called Kepler-90I. It, too, is the third planet from its Sun, but with an estimated surface temperature higher than 400 degrees Celsius, it's probably not habitable. Story continues below. Graphic to 7 previously known planets in this system range from small, rocky worlds like Kepler-90I to gas giants, which are all packed closer to their star than Earth is to the Sun. It's very possible that Kepler-90 has even more planets, study co-author Andrew Vanderberg, an astronomer at the University of Texas at Austin, said in the teleconference. There's a lot of unexplored real estate in the Kepler-90 system. Astronomers have identified over 2,300 new planets in Kepler data by searching for tiny dips in a star's brightness when a planet passes in front of it. Kepler has collected too much data for anyone to go through it all by hand, so humans or computer programs typically only verify the most promising signals of the bunch. That means that worlds that produce weaker light dips, like Kepler-90I, can get passed over. Vanderberg and Christopher Shalou, a software engineer at Google in Mountain View, California, designed a computer code called a neural network, which mimics the way the human brain processes information, to seek out such overlooked exoplanets. When a planet crosses in front of its star, Kepler sees a small dip in starlight as indicated by the white line. But if the signal is weak, like the light reading produced by Kepler-90I blue dots, it can be hard to distinguish from meaningless noise. Researchers previously automated Kepler data analysis by hard-coding programs with rules about how to detect bona fide exoplanet signals, Coughlin explains. Here, Vanderberg and Shalou provided their code with more than 10,000 Kepler signals that had been labeled by human scientists as either exoplanet or non-exoplanet signals. By studying these examples, the neural network learned on its own what the light signal of an exoplanet looked like, and could then pick out the signatures of exoplanets in previously unseen signals. The wide-range neural network examined 670 star systems known to host multiple planets to see whether previous searches had missed anything. It spotted Kepler-90I, as well as a sixth, Earth-sized planet around the star Kepler-80. This feat marks the first time a neural network program has successfully identified new exoplanets in Kepler data, Jesse Dotson, an astrophysicist at NASA's Ames Research Center, said at the teleconference. Vanderberg and Shalou now plan to apply their neural network to Kepler's cache of data on more than 150,000 stars, to see what other unrecognized exoplanets it might turn up. Coughlin is also excited about the prospect of using artificial intelligence to assess data from future exoplanet search missions, like NASA's TESS satellite set to launch next year. The hits are going to keep on coming, regarding potential exoplanet signals, he says. Having self-taught computer programs help humans slog through the data could significantly speed up the rate of scientific discovery. The Kepler-90 solar system is like a cinctured-up version of our own. Small rocky planets hug the star most tightly, while larger planets hang back. But as seen here, all 8 planets' orbits are packed closer to their star than Earth is to the Sun.